is my next video lecture and this is on beta function. This is represented as beta and there are two parameters m and n. Okay. So what is the definition of beta function? Beta mn is equal to 0 to 1, this is the limit, x raised to power m minus 1, 1 minus x raised to n minus 1 dx. And m should be greater than 0, n should be greater than 0. Okay, so first thing that you should remember is that here it is a two parameter function. Okay, unlike gamma, where gamma was gamma n is equal to 0 to infinity e to the power minus x raised to n minus 1 dx, where n should be greater than 0. It cannot be equal to 0. Here also these two cannot be equal to 0. Okay, so this is the symbol for gamma. I hope you remember it. It was in my one of the video lectures. You can refer it back if in case you forget. So this is gamma function. It is a single parameter function and it is 0 to infinity, and there is an exponential term and there is a x term. Okay, x raised to this power, and n is the parameter which comes here. But in beta function, it is 0 to 1, there is x and there is 1 minus x. So that the total sum is always between the range 0 to 1. Okay, this raised to power m minus 1, this raised to power n minus 1. Now this m, whatever is there, it comes first. Whatever is the power of 1 minus some term, that would come in the second parameter. Okay, it doesn't matter here there is x or y or z or a b c d, whatever it can be, but it should be raised to some power m minus 1, and that m would come here, and 1 minus that thing, n should come here. Okay, so this does not depend on x, it depends on m and n. This is what I want to say. Okay, now let's look into the properties. Okay, so first property is beta mn is equal to beta nm. This is a very important property and this is known as symmetry. Okay, why it is called symmetry? Because m and n can be interchanged. Okay, this is very important property because beta 2 1 can be simply written as beta 1 2. So there is no difference in between two. If you write 1 before 2 later, or you can simply interchange in any of the expression whenever there is a beta, you can interchange m and n. Okay, so they both are same thing. Okay, I can also give a proof before going into the next property. It's very easy to prove this. So let me start from the LHS side. What is LHS? Beta mn. And we know from the definition, we can simply quote it here. 0 to 1 x raised to power m minus 1, 1 minus x raised to power n minus 1 dx. Right? Now I'm making a substitution. Let 1 minus x equal to y. Okay? Let. So from here I have x equal to 1 minus y and minus dx equal to dy. Okay, so let me put it here. What is x? 1 minus y. So 1 minus y raised to m minus 1. What is 1 minus x? It is y. Y raised to n minus 1. Remember, m and n do not get affected by this. And dx becomes minus of dy. And what would be the limit? Since x is 1 minus y, here when x is 0, here x is 0, y, what is y? Y is 1. When x is 1, y is 0. So this is just the opposite limit as it was here. Okay, but one thing we should see here or observe this, there is a minus sign with dy. Okay, and we know from the properties of integral that whenever there is a minus sign, we can just reverse this. Okay, we can flip it. So it becomes 0 to 1. 1 minus y raised to power m minus 1, y raised to n minus 1 dy. Okay, now we generally write this term, single term here, and 1 minus y term later. Okay, this is a product. I can simply interchange. I can write AB as BA, right? So what I'm doing is I'm bringing this term in the front. 1 minus y raised to m minus 1 dy. And now you must have guessed what this is. If you compare it with the definition, something raised to m minus 1. Okay, it can be x or y. I already told it does not depend on the variable. So something raised to n minus 1, 1 minus something raised to m minus 1, and the limits are 0 to 1. This is nothing but beta function for sure. Now whatever is here comes first. So it is n, then m. So we started from beta mn and we ended into beta nm, and that is nothing but RHS. Hence we have proved that beta mn is equal to beta nm. Hence the symmetry property is correct. Okay, let's do the next property, which is a very important property, and it is the relation between beta and gamma function. Okay, so beta mn is nothing but gamma m into gamma n divided by gamma m plus n. Okay, so there is a very important crucial relationship between these two functions, and whenever you reach to beta function you can easily solve in terms of gamma function, because gamma again ends up into factorial, right? So for example, let me tell you beta 2 3, suppose this is the thing that comes out finally. So we can always find the value of this, because here it's gamma 2 gamma 3 by gamma 5, 2 plus 3. Now we know what is 2, gamma 2 is 1 factorial, okay, because gamma n is n minus 1 factorial. So this is a relationship between gamma and factorial. This is the relationship between beta and gamma. So we know the relation between beta and factorial as well. Okay, so these three are interlinked to each other. Now what is 3 factorial? 3 gamma, 2 factorial. What is gamma 5? 4 factorial. So we got the value of beta 2 3 as this thing. You can further simplify it and get the value, right? So there is a relation between beta and gamma that we know here, and there is a relation between gamma and something, that factorial. Okay, so we can easily find they all are interlinked with each other. Whenever we reach to beta we can get gamma, whenever we reach to gamma we can get a factorial, and factorial we can easily solve, right? We know it. Okay, there is one more property of beta mn. Actually this is another representation. Instead of writing it in terms of 0 to 1, here we write it in 0 to infinity x to the power m minus 1 dx divided by 1 plus x raised to m plus n. This is also one more property of beta mn. And since we know we can interchange m and n, right? From our first property, we can interchange because they are symmetrical. So instead of m, you can always write n. And instead of n, you can write m. So this remains as it is. M plus n becomes n plus n, since both are same. So this is also a representation of beta function, right? But this is the most commonly used, okay? There's one more representation of it. Beta mn is equal to 2, 0 to pi by 2 sine raised to power 2m minus 1 theta cos raised to 2n minus 1 theta d theta. Okay, this one. So till now we were doing algebraic kind of relation between the beta functions, right? But here this is a trigonometric relation for the beta function. Okay, so I will derive this very quickly. It's very easy to derive. You just have to substitute the value of x as sine square theta in the main definition of beta mn. So what is the main definition of beta mn? 0 to 1, x raised to m minus 1, 1 minus x raised to n minus 1 dx, right? Now I just substitute x as sine square theta. I have dx is equal to 2 sine theta cos theta d theta, right? Let me put it here. This will be 0 to pi by 2 because sine 0 0, sine pi by 2 is 1. Okay, here it is sine square theta raised to power m minus 1. What is 1 minus sine square theta? Cos square theta raised to n minus 1, 2 sine theta cos theta d theta, right? Fine. This can be simplified further to bring sine terms together and cos term together, and this 2 would come outside. So this is 2m minus 2, right? And this plus 1. Similarly for cos, 2n minus 2 plus 1 d theta, right? I've clubbed together all the terms of sine and cos. So this actually becomes sine raised to 2m minus 1 theta cos raised to 2n minus 1 theta d theta. Okay, so this is the expression for beta mn, right? Okay, so this can be further simplified. How? If I simply write 2m minus 1 as p. Okay, it might be looking 2m minus 1, 2n minus 1. Let's simply put this as p and this as q. So 2n minus 1 equal to q, right? So what is the value of m? P plus 1 by 2. What is the value of n? Q plus 1 by 2, right? So what is this then? Beta mn, right? That can be written as beta p plus 1 by 2, comma, because m is p plus 1 by 2. What is n? Q plus 1 by 2. And that is nothing but 0 to pi by 2 sine raised to what? P theta, right? Because I have substituted 2m minus 1 to be p, just to make it more simple. Cos raised to power q theta d theta. So this is also a definition. Beta p plus 1 by 2 q plus 1 by 2 is equal to sine raised to p cos raised to q with a 2 here. Fine. Okay, so let me do a question that will make you very clear about this. Sine raised to power 6 theta, cos raised to power 4 d theta. Okay, very simple. So you can see whenever you look into this form, you know this is of this pattern, right? So what is my answer? Here, what is my P? That is 6. What is my Q? It is 4, right? So my answer is nothing but beta P plus 1, that is 6 plus 1 by 2, comma, Q plus 1 by 2, that is 4 plus 1 by 2, right? And since there wasn't a 2 here, so we have to divide here by 2. So this is my answer. Okay, since there was no 2 here, I multiplied with the 2 and I divided with the 2. Since I divided with the 2, I have to divide this side also. Okay, so the answer is half beta 7 by 2 comma 5 by 2. Now suppose the option is not given in this form, we can convert it into gamma and then into factorial. Okay, we know this property of gamma. What is gamma n? N minus 1 gamma n minus 1. Right, one step we reduce, okay, for gamma. By using that, we can make it, this is beta 7 by 2, 5 by 2, right? So how to further simplify it? Half, first of all, let me put it in terms of gamma, right? So gamma m gamma n by gamma m plus n. So gamma 7 by 2, gamma 5 by 2 divided by the sum of these two, 7 plus 5, 12 by 2, gamma 6. Gamma 6 we easily know is 5 factorial, right? So in my denominator, I have this 2 and 5 factorial. Now I have to solve the numerator, right? What is numerator? 7 by 2 gamma and 5 by 2 gamma. This we cannot say it is a factorial because this is only for integers, right? This one, gamma n is equal to n minus 1 factorial. This is for integers, right? This is for fraction. So I will use this one. So what is gamma 7 by 2? It is 5 by 2 gamma 5 by 2. Easy. Now I have to again split it. So this is what 5 by 2 is as it is. This is 3 by 2 gamma 3 by 2. Right? Then further 5 by 2 is there, 3 by 2 is there. This will be half gamma half. Now we know what is gamma half. I told in my video lecture for gamma function, it is root pi. Okay. So I have 5 by 2, 3 by 2, 1 by 2 into root pi. I have solved this, right? I have solved gamma 7 by 2. Similar way, I can solve gamma 5 by 2. Okay. So let me solve gamma 5 by 2. That is 3 by 2 gamma 3 by 2. That is 3 by 2 into half gamma half. That is 3 by 2 into half into root pi. Okay. And what was my final answer? Gamma 7 by 5, 7 by 2, 5 by 2 divided by 2 into 5 factorial. So what is gamma 7 by 2? It was 5 by 2 into 3 by 2 into half into root pi. And what is 5 by 2? 3 by 2 into half into root pi divided by 2 into 5 factorial. So you just simplify and this is your answer. Okay, it's very easy. Okay, when you see that structure, you can easily solve it and reach the correct answer. Okay, now let me do one more question. And this question I am doing it for a trigonometric form. Okay, so that it becomes clear how to tackle this type of question. 0 to infinity 1 plus x square whole raised to power 3 dx. Okay, this is the question that is given to us. Okay, now looking at this question, nobody can tell, oh, it is a question in which we can use beta function, right? But and how to also solve this, it is like kind of how to proceed, it becomes a difficult thing. Okay, but always remember, whenever you have this form 1 plus x square, okay, in the denominator or wherever you have this 1 plus x square, simply put x is tan theta, because we can utilize this property 1 plus tan square theta is sec square theta, and things become really easy. So this is one of the tip or trick you can say that I am going to give you today, that is 1 plus x square is there in the integral question. You just substitute x as tan theta. Most of the times it will work and it will help you to simplify in terms of sine and cos. Once you reach to sine and cos, that is beta function. Okay, or you can also solve by using trigonometric identities if you remember it very well. But beta function is a very good way to solve. Okay, and sometimes the answer is also in the form of beta functions. So just let me put x equal to tan theta and dx would be sec square theta d theta, right? So I have 0 to pi by 2. Okay, because tan pi by 2 is infinity. Here I have tan theta by sec square theta raised to power 3, and dx is sec square theta d theta. Okay, so I have 0 to pi by 2 tan raised to power 3 theta divided by sec raised to power 6 theta into sec square theta d theta. Okay, this becomes 0 to pi by 2 tan cube theta into sec raised to power minus 4 theta d theta, right? Now we can simplify it further by writing in terms of sine and cos, because we know tan is sine by cos raised to power 3, and here sec is 1 by cos theta raised to power minus 4 d theta, right? Okay, so now 0 to pi by 2, what is sine raised to 3 theta? This is cos 3 theta, and when this goes, minus 4 becomes plus 4. When it goes into the numerator, it becomes this form. This is 4. Okay, so I have 0 to pi by 2 sine cube theta into cos theta d theta. Okay, now once you have reached here, you have reached to the answer. Okay, it's very easy. You know this format, what it would be. Okay, how you can solve it? I told you one identity which was in terms of sine, right? So it was beta p plus 1 by 2 q plus 1 by 2. Okay, take half this side, equal to 0 to pi by 2 sine raised to power p theta cos raised to power q theta d theta. Now you can do it. What is p? 3. What is q? 1. That's it, you put it here. So it is half beta 3 plus 1 by 2, 1 plus 1 by 2. So it is half beta 4 by 2, 2 by 2. So it is half beta 2 comma 1. And also you know this is half beta 1 comma 2. So whatever is given in the option, that is correct. If both are given, both are correct. And if it is not in terms of beta, you simplify it, because you know second property, which is beta and gamma relation. So this is gamma 2 gamma 1 by gamma 3. Okay, that is half, and since all are integers, very easy to solve. 1 factorial 1 divided by 2 factorial. So it is 1 by 2 into 1 by 2, that is 1 by 4. This is my answer. Okay, so very easily we reached from here to here. What is the key step? Put x as tan theta whenever you have 1 plus x square. Okay, so I hope you have understood beta function and also the examples that I have used. And if you have any doubts, please comment, and if you like my videos, please share and subscribe. Thank you so much for watching. Thanks a lot.